Okay, so here's an example of zeros at the beginning of a number and in the middle. These 4 zeros are not significant. These 3 are, because they're sandwiched in between 2 non-zero numbers.
Ice cream sandwich.
Yes, and the ice cream is the 0. Yes, sir. There are, yes. Okay, I'm going to give you a couple of more examples. I want you to also copy these into your notes and then see if you can figure out how many significant figures there are. Let me think. Yes?
Oh, he looks like you're.
Only some of the times. Okay, so let's look at these examples. 12,003. How many significant figures?
5.
Good. 0.00802.
3.
This one?
5. 4.
How do we feel about this? Good?
What about yours? Phenomenal.
Yeah, let's talk about zeros at the end.
Phenomenal.
Okay, so we already had, excuse me, a never. Zeros at the beginning of the number are never significant. Zeros in the middle of a number are always significant. So what do you think would be the case for zeros at the end of a number?
If it's a never, then why do we have 10.00? Why do we always have 2 zeros instead of 1 times?
It's a sometimes. So what about the sometimes? Okay, so here is the rule. And really this is infallible and it's pretty easy to figure out. If there is a decimal point anywhere in the number, at the beginning, those zeros at the end of the number are significant. So ask yourself, is there a decimal point? If the answer to that is yes, the answer about those zeros at the end is also yes. They are significant. That's why you do write 10.00. Because as long as there's that decimal point, you're saying that those zeros are meaningful. That's why we do it. If they had no meaning, we wouldn't do it. We would never write 10.00. Cole?
Why are they meaningful? Because 10.00 is just 10, but with more work.
You're right. So why do you do it? And the reason is because of your experimentation. So 10.00 to me does not mean the same as 10. 10.00 to me means that I have measured it in an analytical way that I know with certainty that it's exactly 10.00. If I see the number 10, it means that somebody has eyeballed some stuff. Eyeballing and analytical measure, to me as a chemist, are not the same thing. Does that make sense as to why that is? So where else would this matter? Nowhere else.
Building.
It really only matters, like actually matters in chemistry. Yeah, it would matter in building. And so there is some sort of significance there. You can't just say that I need my room to be 10 by 12 feet because, you know, my 10 feet might not be the same as your 10 feet. But really, it's also not the same if you don't use the same measuring tool as well. Yes, sir?
So I think you talked about this in last physics class, but we don't do safe things in physics, right?
We do not.
Okay.
We do not.
No,
We do not, yes. See. Okay, so that means that the opposite also is true If there is no decimal point, your end zeros are not significant. So Logan, you did a thing and it was a trigger to me and it has nothing to do with you, so please do not feel like I'm at any way irritated with you. You just started repeating what you learned. So those of you who had Mr. Dermis last year, God love him, he called them sig digs or significant digits. That's not what we call them. They're called significant figures. Do they mean the same thing? Yes. And like if you call them sig digs, I will totally know what you mean. But to me, that's not what they're called.
It was so funny because some of the people that extremely mad at you.
Well, yes, and that's the thing. So if any of you guys are going to college and you take science classes in college, you will hear, you will just hear professors like absolutely lose it over the littlest things. Like, for example, we know, because I've taught you, that when you write charge, the number comes first and then the plus or the minus. Because to me, as a chemist, this means something different. This has a separate meaning than what this means. Now, you are a chemistry student, and it's okay that you don't know what the meaning is yet. I will teach you it. But there's a reason that we do things the way that we do because it has meaning. So it's not just an arbitrary thing to make your lives miserable. I mean, it might seem like that because a little bit it is. But it does have meaning, and it is a purpose. Yes, Demetrius?
Mrs. Schramm taught us the same thing about the Oxford comma.
What was her feeling about the Oxford comma? Was she for it or against it?
I don't remember, but she did tell us that in college there would be like some people who are very strong about it.
Yes, one way or the other. Like they come down on it, and it's like you would think the world is absolutely ending over this one tiny little thing. I am pro Oxford comma.
I hate chemistry.
That's not what we're out on about, Callan. But I mean, Gaden, I'm sorry. I don't know why you called you Callan. I don't know where that came from. But yes, no. The Oxford comma is another thing. Okay, so let's put all of this together. I'm going to write a whole bunch of numbers on the board. I want you to think about what the significant figures are for each of these numbers. And then, when you know one, I'm going to switch colors and you're going to write how many significant figures there are next to that number. Yes, Cody, do you have a question?
Like at the end of class, is there going to be work time or free time?
Maybe.
We're gonna have homework.
Maybe. Let me see.
Is the Oxford comma the comma with like 31,000?
No, Oxford comma is like before the last thing in a list. So if I said, I like to eat peanut butter, jelly, and pickle sandwiches, I would put 2 commas in there.
What?
I don't actually like that.
wanna
I
try
just
that now.
was making it. Okay, that's gross. We'll do that in a minute.
Peanut butter and jelly.
Wait, what? 2, 3, 5.
What happened?
Okay, do what you can on these in your notebooks. You need to have some examples of correct answers so that you can go back and look at them later on. And when you think you know the answer to one, come on up here and write it. I'll do one for you. I think this one has 5 significant figures. You may. Yes, Gabe?
Is that a point at the bottom?
This one?
Yeah.
It is. Thank you, intrepid soul. Well done, that is correct. You can give it to Gabe.
We're only allowed to answer one, right? At a time.
Yeah, if you see it, if you live, how many people we got? Yeah, because we've got some people who are willing to take a guess here. In second block, where there weren't as many people who were willing to put themselves out there.
How come you wear your watch on your right hand? Because it just feels uncomfortable on my left hand.
Oh.
I wear my watch. Why don't I never really wear my watch.
I'm so fascinated by people who wear it on their dominant hand because it's
I just can't. I try wearing it on my left, and
it feels too weird.
Yeah.
Interesting. That's awesome.
My kneecap hurts.
Oh. Why are you not? You don't got your brace on?
No, I do.
Oh,
It's under my pants.
it's under your pants. Okay. Oh, I like your Santa socks. Let's see. This is week 8 of school. So after this week, we have 10 weeks until Christmas.
I don't know where it goes.
I know. We're getting there. All right. Does this have 2? Yes. 3? 5? 5?
Yes.
3? 5? 3? 4? Yes, that's true. This one at the end here is not significant. 2? 4.
Wait, wouldn't the one with, no, how was, wouldn't,
That one's 3.
oh shoot, that's a decimal, not a comma.
It is, yes.
No, I'm looking at.
At this one?
16.0.
Oh, yep, that's a decimal point. Yes. Yes.
Isn't 31,000?
31,020, is that, yes. Well, these 4 would be significant and this one's not.
Oh, I forgot that.
Because there's no decimal point in that number.
Sandwich rule.
Oh, yes, that one is, yep, because of sandwich. Yep. All right. How much do we remember about scientific notation?
Yes, all of it.
Okay, I'm just going to give you a very brief review. If this is too confusing to you, come see me during Jet Block tomorrow and I'll give you more of a tutorial. So, for significant figure purposes, if you're looking at a number like 4.30 times 10 to the 4, I'm going to say this and then I'm going to repeat myself several times because this is what people were not, like, I said it several times in second block, but they were not listening. You look to the left of the X. Everything here is just a placeholder, so we just don't need to even pretend that we can pretend it doesn't exist. So for significant figure purposes, this is not necessary. So how many significant figures here?
Right.
Correct. Because we don't worry about what that is. Okay, so remember, when you're making a number, like our 31,000 from the last slide.
Wait, Miss Bishop?
Yeah.
There.
No, that 0 is significant here, Cannon, because there's a decimal point
Okay.
in the number. Good question. Okay, so how many significant figures are in this number? Okay, there's no decimal point, right? But we know that the decimal point exists. It's just not written. Where is it?
Behind the 0.
It's here, right? But our original thing should only have 2 significant figures. So keep that in mind. In scientific notation, what you're going to do is have only one non-zero number to the left of the decimal point. Here we have 5 numbers total. So we're going to have to move this decimal point from the end to right here. So we're going to count how many times we move it for each place, like for each number. 1, 2, 3, 4. And so my final number should be 3.1, and I'm dropping those 3 zeros because they're not significant. And then it should be 10 to the 4 because I moved my little red decimal point over 4 times. This is the proper answer. Now, how do you know if an exponent is positive or negative? I have an easy way for you to remember this. If your original number is greater than 1, it's a positive exponent. And if your original number is less than 1, like so for example, if you had 0.00219, that number is less than 1, you will have a negative exponent.
Oh.
Yes, Mason?
So, so you do this, but I'm asking anyway. So if you have a number like 31,412, what would you write for the scientific notation? Because I'm assuming you don't want to use every single number in scientific notation.
You do though, because if your number is written like this, you have 5 significant figures. So
you use all of them.
you would use them.
Okay.
Yep. And so this would be times 10 to
Then does the technically using the scientific notation make it longer?
I mean, yes, but it's a lot easier to lose digits when you have a number written like this than when it looks like this. Demetrius.
4.30 times 10 to the 4th power in normal form. That only have 2 significant
Oh, yes, it would. I have a way to work around that, but I'm not going to teach you that until Friday. So stay tuned.
Miss Fish.
Yes, sir.
On the second one, on the bottom one, you want the decimal between the 2 and the 1 or the 1 and the 9?
Between the 2 and the 1, because you want one non-zero to be to the left. So my one non-zero would be in the 2. And so that would be 2.19 times 10 to the minus 3.
I thought you could only have one thing.
Say that again?
You could only have one.
There's one digit to the left of the decimal point.
Oh.
Other left.
Oh.
Other left. That's what my piano teacher would always say. When he would say, okay, do that with your right hand, and then I'd invariably use my left hand, he'd say, your other left, or your other right.
Wait.
All right, what I want you to do is go back to that list of numbers that you should have in your notebook, and I want you to practice putting all of these numbers into scientific notation. Joe, put it away.
I was just.
Well, what if they're already decimal?
What?
What if they're already decimal numbers?
Like which one?
Like the 6.2.
So this is already in scientific notation. So what you would write it as, you could leave it like this. The most proper thing to do would be times 10 to the 0.
Okay.
You don't need to write times 10 to the 0, but for those of you purists out there, that is the most proper way. All right, so when you think you have the right answer, come on up here and somewhere on the board, write where you think it should go, the correct scientific notation with the correct number of significant figures.
Good old pencil.
That's the good old pencil. Where did you put your decimal point?
Oh, yeah.
Oh, okay, thank you. For a minute, it looked like it was after the 2.
Oh.
And I thought, well, that can't be right, but you're good.
I
4. No, you're right. Good job. Good job, Cole. You were right.
Wait. I did that wrong.
You did do it wrong.
Yeah, they're supposed to be.
That's like.
but wait a minute, Madison. Just hang on a second.
Oh my god, now I wrote it. I got this. How did I write it wrong?
Okay, but you can only have one number to the left of your decimal point. So your decimal. Oh.
Oh yeah, 'cause it has to be. Oh my god.
So your 10 to the 3
No,
is
yeah.
good.
Yeah. I,
No, don't feel bad. Don't feel bad. There you go. 0,
oh my god.
3, 0. Yep, times 10 to the 3. Yay! Yay, you got it.
Oh my god.
No, that's okay. That's okay. That's okay.
Okay, basically.
Hey, hey, hey! I'm feeling $2 offended.
Okay.
I'm Madison. You do not use our knowledge as a weapon. Cody, you better get your butt up there.
Yeah, Cody.
Put your money where your mouth is, Cody.
You are probably one of the dumbest people.
Damn, you stole my.
Hey,
I'm
Joseph!
telling. Yeah, it's whatever.
We're not using our knowledge as a weapon.
Bishop, I wasn't saying that I'm stupid.
Yeah, well, we can't use
Yeah,
in the
first,
same way we
what?
cannot insult people for their lack of intelligence or our perceived lack of their own intelligence. Mason.
0, 2.
If it is just by 1,
Yes.
okay, so
Yes, you should. Some people will leave it as 10 to the nothing. I don't think that's proper. I think you should write 10 to the 1. That's how I would do it.
I'm just saying, I only asked you because you guys were.
I mean, it would be something enough that I would mark it wrong.
I did.
Grab it up.
Did I walk it? Yeah.
Good job. All right, let's come back to.
Hypothetically speaking, I just flipped off the camera. What would you do?
I would be with $4 offended. You better plan on taking Jake home from team dinner tomorrow night, my guy.
I did it. You can go over it. I did it.
I was just making sure.
All right, is this one correct?
Yeah.
Thumbs up. The decimal is right here. My aspect ratio on this computer is way off, so that's why it looks like it's a Halloween font. Is this one correct?
Yes, because I did it.
I love the confidence. Very good. Is this one right? It's not right. I don't know who did it, so I'm not going to single you out because I don't even know.
No.
You need 5 significant figures.
I put the 1.
So you really, these 3 zeros are significant because there's that decimal point. You have to retain them. This one's okay. I like the X better than the dot. That's okay. I did that. That's okay. This one's okay.
How's the bottom up?
Nobody did this one.
And no more bubblers for you.
Times 10 to the 4. This one is good. And that one is good too. Any questions?
Wait. Oh yes, never mind.
Any questions? How are we feeling about this? Okay, so if we get this number on our homework, how many significant figures? 5, is that correct? It's what's to the left of the X. So you look at that, and this is nothing to worry about. All right, I'm going to give you. Oh yes, Demetrius. Guys, quiet. I heard that. Go ahead, Demetrius.
So is the amount of significant years in scientific notation supposed to be the same as the amount?
In your original number, yes.
Miss Bishop,
Yes, sir.
how come you don't get the minus 20 in this significant?
Because that minus 20 really means that we would move this decimal point out 20 times. So
Yeah.
19 of these zeros. None of those zeros are significant because they're just telling you how small the number is. They're not there for any other purpose.
But they're after the. Okay, never mind.
In the same way that like this is the chemistry number that we'll be using quite a lot of in a couple of weeks. Avogadro's number. This means that you would move the decimal 23 times. It's a really big number, but we don't worry about all of the rest of those zeros, those other 20 zeros, because there's no piece of machinery that can measure anything that precision, that precisely. Words are hard. All right, I'm gonna stop this. If you guys have questions, let me know.